All right, so now let's talk about vulnerability scanning. So there are two common tools out there, and there's several others, but OpenVAS and Nessus. And these are two automated tools for finding vulnerabilities. So what is vulnerability scanning? So this is where you use automated tools to identify known weaknesses in systems, applications, network devices, and you compare observed configurations and service versions against databases of thousands of CVEs, and it produces a prioritized list of findings. So Nmap has vulnerability scanning. This is vulnerability scanning with a lot more. So what these systems do is they connect to those target services, read banners, probe for version information, check configurations. They compare it against the CVE database, so NVD, vendor advisories, and they'll generate findings with the CVSS score, which is a score between 1 and 10. They don't confirm the exploitability. All they do is they just identify those potential vulnerabilities. And so a finding is a candidate of a exploit, but it's not necessarily confirmed to be one. So what a penetration tester would do is they would run OpenNAS or OpenVAS or Nessus against an environment and then take those findings and then manually check each one to verify whether or not that is an actual vulnerability. And then there is the CVSS score, which is a common vulnerability scoring system. It's rated from 0 to 10, not 1 to 10, where 9 and 10 are critical, high is a 7 to 8.9, medium is a 4 to a 6.9, and low is a 0.1 to a 3.9. So CVSS version 3 accounts for attack vector, complexity, privileges required, and user interaction. So CVSS is a industry standard way of identifying vulnerabilities and identifying exploits as to how dangerous they are and what the likelihood that they would be used for compromise. So looking at OpenVAS versus Nessus, and these are the two common ones out there. So OpenVAS is free and open source. Nessus is free and paid. So there's a free version which will let you do a limited scanning. There's a paid version which will let you do quite a bit more scanning. If you are working for a business, typically you will be using the paid version of Nessus. If you are working by yourself, or if you are working for a small company which is doing this, you may end up using OpenVAS because the free version of Nessus just isn't really worth it for anything, because Nessus Essential only allows you to scan 16 IP addresses, which is not that much in a really any environment of any scale. OpenVAS does have a fewer number of plugins than Nessus does, and Nessus gets updated quite frequently. But for some, especially smaller businesses, OpenVAS is usually going to be sufficient enough for whatever is needed. So OpenVAS is good for medium networks. Nessus is good for enterprise-sized networks. Both will work. It's just OpenVAS is going to be a little bit slower. There is reporting for both of them. You can pass in credentials for both of them. So if you have known credentials for some systems, then you can add that in there as part of your scanning methodology to try to authenticate via SSH or SMB or other methods. They both support CVSS. Both will work on Kali. Typically Nessus would be a separate system that is set up. They both have a web interface for interacting with them. So it just really kind of depends upon how much money you actually have to spend on this. So OpenVAS, this is partially installed on Kali, but really to install it, what you have to first do, you can either do a apt install GVM, or if you just do an apt install OpenVAS, it will install all the tools. The reason for GVM is it's now it's now owned by a different organization, and I can't remember what GVM actually stands for, but everybody still refers to it as OpenVAS. So once you install it, the first step you do is a GVM-setup. And that takes a while. It could take, depending upon the speed of your network and the speed of the system, could take an hour to 2 hours to actually run through. Once it is finished, and that entire process, what it's doing is it's downloading all of the scan information, the CVEs and everything else to build its own database. And it's running a PostgreSQL database on the system. And so it's downloading and indexing all of that. Once it's finished, and this is really super important, it will print out a bunch of information. You need to scroll up a little bit, and it will list the default admin username and default password. Default username is admin, but the password is going to be a separate UID that is, or UUID that is in there. So what you need to do is you need to copy that and save it somewhere. And then you run a GVM-check-setup. And this doesn't take that long. It just verifies that everything is downloaded and installed correctly. And then you run a GVM-start. And that will actually start the process and the services. Once that is done, then you can open up the browser, Firefox or whatever, and navigate to 127.0.0.1:9392. The key important thing is you have to make sure that it's HTTPS. Firefox, for some reason on Kali, by default, when you type in the IP address :9392, it assumes it's HTTP. Well, it's not running on HTTP, it's running HTTPS, so you have to go in there and change that. Once that comes up, then you can log in with that admin username and the password that was saved when it went ahead and configured it, and then it will bring up OpenVAS. Then you wait. Literally, you wait potentially 2-3 hours or more. The first time I ran this, I was running it on my system here with 2 CPUs, and I think I gave it 4 gigs of RAM, 2 CPUs, and I waited about 2.5 hours, and it still was building its feed, and I went to sleep. The next morning, everything was fine. But when you first log in on the dashboard, it will say that it's building the feed, and you can't do any scans until it's finished. So all you have to do is just start it up and then walk away from it and let it continue running, and eventually it will finish. Once it's finished, then you can go ahead and start doing the scans. And there's a homework out there which will have you do this, but basically you can specify, you can do a scan and then a task to create a one-time scan on a specific IP address. You can also go to the devices and you can create targets, and it will support IP ranges and all sorts of other stuff. So you can feed that all into the system, and then you can create a new scan to scan across an entire range of targets. If you run it on just one target, and again, there's this homework assignment, or actually this will be the lab on the Metasploitable system, running it against that one host, which is on the same computer because it's all virtualized, takes about 45 minutes. And what that will do is that will actually go through and scan all the ports and then start looking for services and start indexing everything and listing all of it. So it's not a fast process. And in the real world, and I've used Nessus many times, generally what you do is you set up the IP address ranges, you hit start, and then you go off and do other things for the next day or two while it's going through and scanning all those systems. And then a lot of times it will send you an email saying that it's finished, and here's the, or you can log in to check the results. And at that point, then you can start identifying what services and what needs to be fixed for that. So interpreting the scan results, like I said, if it's a critical, it's going to be a score of 9 to a 10. Those are the ones that you fix right away. If you have any systems which are vulnerable to those, well, they are almost as good as being compromised right now. You address those right away. And as a penetration tester, if you identify any 9 and 10s as part of it, if it is close to the end of the engagement, then you would alert them as soon as possible, especially if it's under active exploitation or it is of a system that could be exploited within the next 24 hours or so. Anything from a 7 to an 8.9 is classified as high. It may not be as easily exploitable. It's still pretty bad, but it needs to be addressed fairly soon. Medium, those are, like it says, it requires specific conditions. Those may not really be that worrisome. And so typically environments will have quite a bit longer to address those. Anything low is things which can just generally wait until that system gets updated or replaced. It's very minimal impact, so it's nothing which really is as bad. But really, it's anything from the 7 on up needs to be looked at as soon as possible, and especially anything from the 9 on up has to be fixed very soon, because those, for instance, shell shock. If shell shock, which I believe has a CVSS score of, if not 10, it's like a 9.8 or a 9.9, that requires a single line of code from a external system to exploit it. And it gives you potentially full root system access to that particular server. So it really kind of depends upon those scores and what is found for it. So info, that's the lowest one. It's not a vulnerability. It's just documenting stuff. So it's not even assigned a score. It's just listed as info. The problem with Nessus and OpenVAS is false positives. You will get false positives. You will get sometimes quite a lot of false positives. They do take steps to minimize the number of false positives, but it still happens. So I've had this problem before where a system was scanned. It was a Red Hat system, and the scanned version was an older version of Apache and PHP. And so it was flagged as a critical vulnerability because of the version number. Well, the problem is that system, that version of Red Hat, didn't support a newer version of Apache, a supported, maintained version of Apache, because what Red Hat does is they backport the community patches into the older version of Apache and older version of PHP. So Nessus was reporting an older version vulnerable to a specific vulnerability when that had already been patched by the maintainers. So when you see a vulnerability, don't immediately assume that the sky is falling and that that's going to be vulnerable to whatever it says. You have to then check and verify that it is actually vulnerable to it and that the patch hasn't been applied to whatever it is. So yeah, like it says, vendor may have backported the security patch without changing the version string. So Red Hat does that. So compensating controls not detected. So again, if you have something which was detected as a vulnerability, a firewall on that system or somewhere else may be restricting access to that service. And so it can reach it, but it can't actually exploit it. So it really kind of depends. So this is why that verification is important. And also non-default configuration. So the scanner only knows what it knows. It doesn't know if there's been changes made to the configuration or anything else. There was another vulnerability which was reported as a vulnerability, but we had already taken steps to remediate it because the official patch was not released, but they had steps on how to prevent that particular vulnerability from happening. And so we took those steps, but the scanner still reported that as a vulnerable system because technically it was vulnerable, but we had blocked it from a configuration there. So false positives, really anything needs to be manually verified because it may not be actually vulnerable to whatever the tool says. So difference between authenticated and unauthenticated scans. So unauthenticated doesn't have any credentials. It's as if an external attacker was trying to break in with no access or just check it. It can only see what is reachable from the network. locally installed software vulnerabilities it can miss, and it will generate much more false positives because, well, it only sees the version, and typical for external penetration testing recon phase. Authenticated is when the scanner can log in with credentials, whether SSH, Windows credentials, or whatever. It can actually look at the installed package. It can identify a lot more stuff. There's fewer false positives. And some scans, so some environments, like if you have a PCI environment or HIPAA, you have to do credentialed scans on systems because that's required by it. So there's a difference between the two, and you may end up doing both of those scans depending upon what the scope actually calls for. Vulnerability assessment workflow, so you define the scope and scan policy. You confirm which IP ranges and system are in scope. You select the scan template. So this is for OpenVAS, discovery, full and fast, full and deep, anything of that nature. Then you run an unauthenticated scan first, and this is the external attacker's view. Once you have run the unauthenticated scan, then you add the credentials and you run an authenticated scan with SSH keys, Windows SMB. You can compare the results, and you will typically find more with the authenticated scan than with the unauthenticated scan. Then you will triage and validate those findings, export the results, sort by the CVSS score, do manual validation on some of them, check the vendor patch notes, mark each finding as confirmed, potential, or false positive. You prioritize it, and then you repeat, and you go through that entire process. So it takes a while, and it is very detailed, but it is very important as part of the scanning process. So takeaways: vulnerability scanners, they'll identify the known weaknesses by versions and configuration checks. OpenVAS, which is free. Nessus, which has a free version, but is very, very limited. Generally, you want to run both credentialed and uncredentialed scan. Credentialed scans will find more vulnerabilities potentially because it can actually log in and check more stuff. CVSS score is severity, not priority. So you prioritize by the exploitability, the asset criticality, and whether compensating controls exist, so like a firewall is blocking it or something like that. False positives happen a lot. So the workflow is you do an unauthenticated scan, then you do a credentialed scan, triage and validate, prioritize by business context, and then you write your report based off of all of that. And as you're doing all of this, you're always taking screenshots and documenting everything that you're doing.